Unit 3, Triangles, Lesson 3.3, Triangle Guts, Part 1. When we're talking about triangle guts, we're talking about the inside of triangles, the inside of triangles. Please note both the location that you're watching this video as well as the date and time. Don't forget to get a parent, guardian, or teacher sign-off as you are watching this video. Let's do a quick recap of our previous lesson, In our previous lesson, we basically learned these two basic concepts. 1, triangles add up to 180. 2, when you have an exterior angle, it equals to the sum of the remote interior angles of any triangle. That's the two basic concepts from the previous class. As you're working these kind of diagrams, you want to hunt for these two concepts in addition to some previous learned materials, such as looking for vertical angles and most overlooked linear pairs. Let's start with those two common ones, vertical angles and linear pairs. I'm going to find two angles, and I'd like you to pause and find the rest yourself. Let's start with 46, and that angle, of course, is vertical. So that's 46. Now I'm going to do one single linear pair. That's 180. So 180 minus 84 is 96. So this angle right here is 96. I'd like you to pause the video, please. Finish finding the rest of the triangles yourself, and then hit play and check your work. Welcome back. Let's see how you did here. So finding that linear pair, you also want to look for this linear pair, 180. So we're going to do 180 minus 46, and we're going to get 134 here. And of course 134 here. And triangles add up to 180. So we have 84 plus 46. And that's 130. Take it away from 180, and of course that gives us 50 here. And a triangle, if this is a right angle, that means this must be 40 here. So in this triangle, we're going to add 40 plus 85. It's 125. Take it away from 180. And of course that's 55. Now double check, see that you found all the angles, all potential angles, including vertical angles and linear pairs, and you have. Now moving on to today's material, the next two lessons are going to focus on what I call triangle guts. What I mean guts, I mean the inside parts of any triangle. The inside parts of any triangle. You're really going to need a straight edge today, and if you have colors handy, you will find it extremely helpful. So if you haven't got it already, get yourself a ruler, please, and colors handy. The vocabulary you're going to walk away from this lesson is the word median and centroid, and of course a midpoint. It says in the diagram below, mark the midpoint of LM point R. Then mark the midpoint of MN point S. Then mark the midpoint of NL as T. Notice you're going to have three different midpoints. I'm going to read these and pause for 5 seconds. Try to draw these on your own and then watch the rest of the video. It says draw a midpoint of LM and label it point R. Attempt to do this on your own right now. Okay, let's see what you did. Label LM is over here. and this is point R, and it's a midpoint, so you should have hatch marks. And I want you to get in the habit, after you account for information, to cross it out. Then take this portion right here. I'd like you to read, mark, now please. Right here, this is point S, and double hatch because it's your second set. Mark MN, midpoint S. Last one. I'd like you to take this sentence, take 5 seconds, and mark it on the diagram. It says right here, that's point T, and that's triple hatch mark. Okay, so we have 3 midpoints here. Now what I'd like you to do is connect the midpoints with its opposite vertex. For example, we're going to connect N with R, and L with S, and M with T. What you have just drawn when you connect a vertex to an opposite midpoint, that's called a median. So all 3 of these are called medians. Let's take a look at the next page and write that definition down. A median is a segment which connects a triangle vertex to opposite midpoint. A median is a segment which connects triangle vertex to an opposite midpoint. So again, let's retrace our steps here. If you have a midpoint here, mark it with a hatch mark. And you had a midpoint on this side. And midpoints have to be designated with those hatch marks or it's not a midpoint. So if we have 3 midpoints here, if we connect a vertex to the opposite midpoint, I'm going to pause and let you catch up on your drawing. Now connect using a straight edge, vertex to midpoint. Please use a straight edge. Vertex to midpoint. Vertex to midpoint. Vertex to midpoint. All 3 of these are called medians. Every triangle has 3 medians. They connect the vertex to an opposite midpoint. Now, if you used a straight edge and you were very careful in the way you eyeballed your midpoints, you're going to notice that they should cross right at a single point. Now, that's not called a midpoint. When the 3 medians intersect, that's called a centroid. Centroid. Now, there is a specific relationship of that centroid that creates on the median. So it's best to actually just feel the relationship. So I would like you to take your thumb and your index finger, and I'd like you to pinch from here to here on your paper. Take your thumb and index finger and pinch from there to there. Physically pinch that distance and hold it. Now transfer your pinched distance between your fingers to this side, right there. If you're really careful, you're going to notice that that distance from the midpoint to the centroid If you carry it over to the other side, it's half of the other segment. So another way we can say is this distance from the midpoint to the centroid is x, then the distance from the centroid to the vertex is going to be 2x. So we have a 2xx relationship. A 2xx relationship. Once again, let's try it this way. We'll call this y. That's y. This up here is 2y. And if this were considered z, up here would be 2z. We have a 1 to 2 ratio from the vertex to the centroid and the centroid to the midpoint. So taking a look at this diagram, I'm going to do the first two and then you do the next two, considering that B, D, and F are all midpoints. Let's see what we can figure out. The segment AG is therefore twice as big as G to D. So it takes 2 of G to D to equal 1 AG. I'd like you to fill the other two statements in yourself, please, and then check your work. Let's see what you came up with. CG. CG is going to be twice as big as GF. So 2 GFs equals 1 C to G. And the third one, EG, 1 EG takes 2 GBs. So we have a 2-to-1 ratio going there. It's a very important relationship that comes into play in a lot of situations. Let's get a little practice here. It says trace all segments, write a thing equation before numbers, use colors. The internal segments shown are all medians. So I want you to do a thing equation before you do numbers. Very, very important. You get in the habit of that, even with extremely simplistic problems like the one we're doing. If possible, use colors. We're told that all the internal segments right now are medians. It's important to know that because there's 3 other internal segments you're going to learn next class. So knowing that they're medians, let's see what we can do here. Medians mean a couple things. Medians, first off, mean that all of these are midpoints. So I'm just going to make hatch marks here to reinforce in my mind that they are all midpoints and then that this is a centroid. So here I'm given h to I is 5.5. I'm asked to find h to j. I'd like you to bracket h to j, please. H all the way to j. Bracket, please. Now ask yourself, what do you know about midpoints? Midpoints means that these two pieces here are equal. So that red is simply 5.5 times 2. So we're going to add, and of course the answer here is 11. Let's try another one. Again, these are all medians, which means these are midpoints. So mark your midpoints. Darken your centroid. J to N is 8. We want to find N to M. I'm going to do a thing equation. Jn equals 2 of nm because of the centroid relationship. This is your thing equation. I know this is simple. You can do this in your head, but I always want you to do a relationship of things before numbers. Just make a habit of it. So here we are told circle, circle, plug it in, 8 equals 2 of nm. So to actually solve here, if this was more complex, you would know how to solve it. And of course, that's going to be 4. Always do things before you do numbers and algebra. Always do things before you do numbers and algebra. Let's try another problem together. We are told that h to k is 24. So let's trace h to k. The whole expanse, so I'm going to bracket and put 24 there. We want to find h to n. That's what we're being asked to find. Now, let's see what we can do here. We know that let's establish this simple relationship. We know the distance h to m is equal to 2 mk's. So in other words, it takes 2 mk's, and then here's another mk to make 24. So we can write this. It takes 3 mk segments to equal to 24. Let's solve. So from here we can figure out that the distance of, not mk, that's nk. N is the centroid there. So it's the distance h to n equals 2 nk's. So nk is 8. That means h to n is 2 times 8, which is 16. Next, we're being asked to find x if we know this concept. U to j is x plus 4. So bracket, I recommend you use colors for this. U to j is going to be x plus 4. Then we're told r to j is x minus 2. Okay, it's really critical that you don't just randomly put algebra together here, that you look at segments before you look at things. We know from here to here, r to j, it takes 2 of those to get from here to here. So ultimately, it takes 3 rj's to make 1 uj. Again, let me recap. Watch the pen. This distance from j to r, there's 2 of those distances up here, so ultimately there's 3 pieces, so there's 3 rj's to get 1 uj. Using that, now you can put your algebra in. So 3 times x minus 2 equals 1x plus 4. Very critical, you just, again, don't randomly put stuff together. Solve for x and plug it in and see what happens. We're going to solve for x here by circling 3, distribute, so now we have 3x minus 6 equals x plus 4. I'm going to minus x both sides. Bring my algebra up here. So I end up with 2x minus 6 equals 4. Add 6 both sides. I have 2x equals 10. And x equals 5. All right, what I'd like you to do now is this page right here, page 28, really stop the tape, attempt these 3 problems completely on your own. Take about 8 minutes and then start the tape again. Please do not just watch the tape. Stop, attempt this on your own, then restart the video. Welcome back. Let's see how you did. We were told that all these segments are medians. So knowing that, these are all midpoints. And this is your centroid. We are told to G to A is 9. What would D to G be? And we know that D to G is half of whatever GA is. So half of 9 is 4.5. Here we're told that C to F is 18. So C all the way to F is 18. We're being asked to find G to F. Really important, we have an x and a 2x relationship going on here. So we're going to make that equal to 18 and solve for x. X equals 6. That means G to F must be 6. And this is 2 times 6, which is 12. They add up to 18. You know you're correct. Now, once again, please do not immediately start meshing your algebra together. Let's look at things first. WK, W all the way to K is x plus 3. We are told F to K, which is right here, is minus 7 plus x. We want to find x here. So once again, remember that this is a 1 to 2 ratio. So F to W equals 2 F to K's. And we know that the whole thing, KW, equals F to W plus f to k. So now we're going to get down to one variable. It takes two of these to get one of those. So our thing equation is kw equals 2f to k plus f to k. kw equals 3f to k. Now we have a simplistic equation to work with because circle, circle, we have 3 negative 7 plus x equals k to w, which is x plus 3. Circle and distribute. Now bring the algebra equation up here. End up with x plus 3 equals negative 21 plus 3x. So for here, I'm going to add 21. Here, minus x, 24 equals 2x. X equals 12. Now, let's see if this is actually true. WK, if x is 12, that's going to be 12 plus 3, which is 15. And now KF is going to be negative 7 plus 12, which is positive 5. That would mean WF must therefore be 10, because it's double, and 10 plus 5 is 15. So we know we have the right answer.